Hey everyone, my name is Makomba Gerard of Edimath. In this video, we're going to look at finding the mean when given the working mean stroke the assumed mean. And if you're new here at Edimath, please consider subscribing and hitting the notification bell. For now, let's get started. When you're using the working mean stroke the assumed mean, capital A, then the actual mean is given by the formula, this here, where this small f is the frequency, and then the d is the deviation, okay, and it's given as x minus a, where this x here is the class mark or the mid value, can be the mid length, mid mark, and so forth. Alright, so we can now start with an example here to guide us on how to find the actual mean when you're given the assumed or the working mean. So here we go, using a working mean of 24.5, capital A is 24.5. They need us to find the actual mean x bar of the data below. We know that x bar is defined as capital A plus summation fd divided by summation f. Now our task is to find d. Then we go ahead to get fd. But we know that d is equal to x minus capital A. We have a, but we do not have x. So meaning that we are going to redraw our table, and we shall have to include columns of x, then we shall have d following, and then we shall end up with fd. Those are the columns that we are going to include in our new table. So here we have our marks, we have the frequency, we shall have x. After getting x, we shall go ahead to compute the d, then we shall finally get fd. So let's go ahead and enter the column of mark and frequency just by copying this to here. Then we need to go ahead and get x by getting the average of the class limits. So 10 plus 14 divided by 2. Here we get the 12. We do the same for this. Here we shall get 17. 20 plus 24, we get 44 divided by 2, we get 22. When we add here, we get here 27. Add and divide the average of that and 34, we get 32. Next we need to get d. We know that d is equal to x minus a. A is the assumed mean, and the assumed mean capital A is equal to 24.5. So we keep on substituting in here, we get the value of d. We know that x is varying in every class. So we start 12, which is x minus a, which is 24.5. This will be negative 12.5. 17 minus 24.5. This is negative 7.5. 22 minus 24.5. We get here negative 2.5. 27 minus 24.5. We are getting here 2.5 positive, and then 32 minus 24.5, we get 7.5. Next we need to get fd. F is here and d is right here, so 2 times negative 12.5, this gives us negative 25. 4 times negative 7.5, we get here negative 30. 6 times negative 2.5, we get negative 15. 8 times 2.5, we are getting 20. 5 times 7.5, we get here 37.5. So the next thing is to get summation d. Summation d here. Then we need summation f. We've got a. So summation f is 25. We need summation fd. So our answer here becomes negative 12.5, right? So it now becomes very simple for us to calculate the mean. We know that mean, if given the assumed mean, this is going to be capital A plus summation fd divided by summation f, right? So we've got summation f, we've got summation fd. We can now substitute in here to get the actual mean x bar. We know that assumed the mean is 24.5 plus summation fd, this is negative 12.5 divided by 25 here. Actual mean x bar is equal to 24.5 plus by 12.5 once, by 12.5 twice. So this is plus negative 0.5. And when you compute properly here, our mean x bar is equal to 24. So that's our mean when given the assumed mean to be 24.5 for this question here. So my dear viewer, I thank you very much for being part of Daily Math. But I would like to leave you with one practice question such that we can concretize the knowledge that we have achieved. So here we go with our tryout question. You can pause the video to have this question written down, and in case you need more clarity, you can play back the video and then you get more clarity. And for more other questions, you can leave them in the comment section. And for now, from us Math, we really appreciate you for being part of our community. And we now say, God bless you. See you in the next video. That will be about measures of dispersion. See you there.